young audience, young people, particularly say graduate students. Let me start with graduate students. I can go back. With graduate students and so on, I think that what tends to be too absorbed in one's thesis problems or in one's the area in which one thesis is. I really strongly advise that people go to department of colloquia, for example, or and try to learn what is happening, advances that are taking place outside your area, because you can make connections. I also advise to take courses. For example, when I was a graduate student, I sat in an algebraic quantum field theory course, which was actually, so it was pure algebra course, actually, modern algebra, but in which I learned things like Gelfand-Naimark serial construction, which is a construction to produce Hilbert spaces starting with algebras or operators. So basically representation. And this has turned out to be extremely useful for me because we got new quantum mechanics, for example, in quantum cosmology. And that new quantum mechanics is coming because one is finding new representations of the algebra which violate one of the assumptions of von Neumann theorem. And therefore you get really completely new field. So this breadth is important and I cannot emphasize it more. However, I should also say that as my own PhD advisor, Prof. Garosh, used to say, your interest should be like a Gaussian. It should not uniformly spread out because then you don't make progress, you will not get a job and such things. But it should be Gaussian. So that is, it should be, that there should be a lot of depth and a lot of understanding in the immediate areas, but we should also have understanding of a lot of other areas. Less and less as you go away and away, but still those can come. Because as you grow into faculty positions and so on, you have less opportunity to learn completely different things. And so what you learn early on can be extremely useful. For even younger audience, I would say that really read, for my generation, it was reading semi-popular books, but maybe here it is more like looking at the online articles and online videos. The problem is that way too many of them, and many of them are complete junk. And so the problem there is distinguishing what to read, what to look at, and what to trust and what not to trust. So perhaps they can get advice from, some reliable professors or something like that. But I think this general understanding the general culture is very, very important. And finally, for graduate students, postdocs, and even young faculty members, I think, it's really important to realize that what you think has been obvious today may be completely superseded in 30 years from now. What was taught to me about how the elements are created in the supernova explosions, about how to deal with the early universe in terms of classical perturbations and so on, that the early universe was chaotic and it was really very, could not be described as perturbation theory, etc. No. And it is all classical. Nobody looks at it that way anymore. Everything is in terms of quantum field theory, it's all perturbative. In other words, the first order fluctuations, maybe second order, but really first order fluctuations. So the worldview can change enormously in 30 years. And, one's career is more than 30 years typically. So it can change enormously. So on the one hand, you should believe strongly and in your own work, whatever you're doing, your basic assumptions. Otherwise, you'll never make progress. But when the work is completed, then you should be your own critic, and perhaps the worst critic, and really examine it and say, well, what are the assumptions? What are the flaws, etc. Not so otherwise you can build up structures on a swampland, on a total swamp, and then it can all sink. So to be extremely critical of one's own work after it is completed is very important. And at least I think that is a hard part of research life on a long range, namely being fully enthusiastic and believing in it and putting all your energy and heart into it when you're doing it, and then detaching yourself and taking an objective view afterwards. There are many people who are very, very knowledgeable, extremely broad knowledge. They don't. I mean, when I was a graduate student, I said, well, if he can't solve quantum gravity, nobody can, because he knows everything. But that was a problem because they know everything, so they see difficulties right away. They don't do the first step. But then there are many others who are many more actually who are in the second step. Maybe they believe what they're doing and they completely ignore all the flaws of their own work. So this balance, I think, is a critical thing. So that is the strongest thing that I would suggest. It is emotionally very hard, but I think that is what is needed. A certain discipline of like that is really needed to have a sustained long range impact. I mean, at your age, you sort of, if you want to do this, right? I mean, everybody has choices, but if you want to really do physics, I mean, it should be in your blood. I mean, you should go to bed thinking about the problem. You should get up in the morning in the shower while you're taking a shower. You sort of still are thinking about it, and then you take a walk, think about it. I mean, you concentrate, and don't look at social media or anything like that. So there has to be this burning passion for it. I think then there will be success. That's the thing.